Yeah, cool. Big hand for Vincent.
Well, first of all, this is my first talk ever, so you're going to see my hands shaking, my mouth is going to be a bit dry, but everything is going to be alright very soon. So, who am I? That's a good question actually. So my first experience with ELK was in France, media time. I was at that time intern as a network architect, and they needed a small infrastructure to monitor all their servers. It was a small project, but it was really good to start discovering the technology of ELK. My second company was OVH. OVH is the third biggest data centers in the world and the first biggest data centers in Europe. I didn't have the luck to work on the Elasticsearch project, but I still kept an eye on all ELK technology during that time. And about 2 years ago, I've been recruited by Blippar, and together with other engineers, we have been able to develop a massive logging system for all our activities. And it's a big pleasure to work for them, and to still work with them. Blippar is a company which is working with all new kinds of visual search technology and augmented reality. And we are still going forward. What is ELK? Like most, who's using ELK in production? Well, that's the first time for me that so many people know what Elasticsearch is. So, just as a quick reminder, ELK is a stack of 3 softwares. Elasticsearch, which is a database, Logstash, which permits us to process all our logs and to put them in Elasticsearch, in simple words, and Kibana, which is the cherry on the cake, and permits us to display beautiful dashboards. And if I had a sentence to sum up what Elasticsearch is, it would come from our Qbox forks. So give me a second, please, because it's actually very complicated to say for me. Elasticsearch is an open source, broadly distributable, readily scalable, enterprise-grade search engine. Good. Every time I see a sentence like this about a software, especially from Qbox, which usually very good feedback about softwares, it gave me a lot of pleasure to discover technology like this. Let me talk about our usage at Blippar of the ELK stack. First of all, we're using ELK as a logging system. We are processing millions of documents per day, from heterogeneous systems like Nginx, HR Proxy, our own internal services. We as well monitor our infrastructure. So, for example, AWS CloudTrail, the auto-scaling, and all the services as well. And finally, we collect all the metrics from our different servers, from containers to bare metal servers. All the metrics, system metrics like CPU, RAM, file descriptors, disk space, but as well software metrics. For example, if we do have a software writing Go, we will collect all the Go routine. And secondly, Elasticsearch as a multi-region database where the latency, replication, and isolation are the more important points. Now I would like to talk about our usage of Logstash. We have here as well 2 use cases. Logstash as the queues listener, we used NSQ as a message broker. And secondly, we collect raw logs from file, which are pushed to Logstash. Previously, thanks to Logstash Forwarder. Logstash Forwarder has something very terrible. I don't know if you looked at it. But the way it used the hosts array in the configuration file, it didn't have any load balancer, and that was something terrible. It means that you can put as much nodes as you want in the host array. It will randomly pick one. And it means for us, we need to install to create a load balancer and to monitor that load balancer as well. So it was just more work for us, and now that's really good. But nowadays, 5-bit does exist, and 5-bit is something great as well. It's a piece of software written by Elasticsearch company. It integrates the bit architecture. I don't know if you heard about the bit architecture, but this is something great. And do not hesitate to look into it. And 5-bit does include its own load balancer, so for us it's really, really good. I would like now to have a quick overview of our infrastructure. So basically, we do have internal services, or, for example, Nginx HAProxy. In that case, we do have a Golang wrapper, which will pass or ask or query some APIs and will format a beautiful, pretty log. We do as well have containers with another containers running logspout. And logspout will bind on the Docker sockets. We'll read everything, and then both of them will push to the NSQ servers. In the case we don't want to push to NSQ servers, it happens sometimes, we can send all the logs into a log file. This one will be handled by a 5-bit, and that 5-bit and that NSQ server will push, well, for the NSQ servers, we will pull the messages to the log/pool. The log/pool is simply some containers or bare metal servers that we scale up and scale down depending on the requests which are made on the log/pool. I would like to say something as well, that's at Blippar, we're using very few configuration files for our log/. I will demonstrate now that with only some key filters, input and outputs for log/ we can manage millions of tokens. As best practice as well, we like to divide our configuration file into 3 configuration files. One for the inputs, one for the filters, and one for the outputs. First of all, the input bits for the 5 bits or any bits software. And the second one, which is basically NSQ input. The filters. It's really important as well to note that all our logs are written in JSON. It permits us to create variables and to obtain a very readable and easily parsable message. And if there is no failure in the JSON parsing, we just mute it and remove the field message, so we don't have duplicate data, and it saves a lot of space as well. Finally, the outputs. Why is to have a good JSON important? That's because, as you can see, if we have the JSON bus failure, we will directly send an email to myself. So if any service if any service sends a bad JSON, it means that something in the pipeline is not good. So we will send an email with the service name, contained usually in the metadata. Every example you have here are simplified as well. There is all the ways to do things, and I hope you will find better ways as well. So usually in the metadata we will have a service and the message that will be sent directly by email. Of course, we encountered issues. We were collecting all the messages, and a daily index on our Elasticsearch per service was weighing around 20 gigabytes of data. It might be not that big, but actually it is at the end of the week, at the end of the month. It causes issues in terms of disk space, in terms of RAM, in terms of even index management. So we decided to introduce something, the index splitting. And we created what we call the summary message. The summary message is a simple but big, containing a lot of information. Oh yeah, thank you. Much better, thank you. The summary message is a big message containing all the process time, all the calls that we have to different sub-services, and all the metrics that we need to produce Kibana servers, and all the rest of all messages will be considered as raw logs. It permits us to create different retention policies per index types. One will be an index with all summary messages, and all other indexes will be raw indexes. So, to achieve this thing, we're going to modify a little bit our filters in Logstash. So in the output, here as well, everything has been simplified for the clarity and to make it easier to read. So if the environment, if our type environment in Logstash contains production or staging, and the message type is equal to summary, then we'll send to an index environment service and the date. Otherwise, if the message is different than summary, we'll send to an index to which we concatenate dash row. It permits us, as you can see, to hugely decrease the weight of an index. On this example, it was last week volume logs for random services. The raw index was weighing around 300 gigabytes, which is actually pretty big. And keeping only the summary and to minimize all the messages into a summary index, it was 1/5 of the raw index, which permits to us as well to save a lot of money, to save a lot of CPU, RAM, and all calculation and space needed by Elasticsearch. We'd like to talk about the Kibana dashboards. So, of course, everything has been sorted. You can see all the references to Lord of the Rings, because I can't talk about what we can do. So, yeah, so it's only using the summary messages. You can see all some latency, some counts as well. What I mean is it took only 33 milliseconds to our cluster to hit over 200,000 documents and to send back the answer. It took over 4 seconds. Wi-Fi was not that good that day. That's why. Anyway, and it's very important to have optimized index, optimized queries, and you will be able to hit very good scores with your Elasticsearch. Of course, we encountered other issues, and that I would like to talk about a little bit. Scatter, which is an option on the network cards on CentOS or Ubuntu on AWS. It has caused us a lot of pain on production servers. So as soon as you want to deploy massive clusters, verify always that the scatter data is deactivated. The heap monitoring. The heap monitoring, what we call it ELK for ELK. It's very important always to monitor the heap of Elasticsearch. We had issues in the past where the heap was overflowed, and now we can analyze and collect the heap using Golang services. And we, in addition with ElastAlert, some pretty simple tools, we are able to send monitoring issues or alerts to Slack or any other component to alert us about a heap overdraw. And finally, the last point, and I think it could be another subject for another talk, is the latency management on multi-region. There is what we call the rack awareness, which is something definitely good to isolate the regions and the shards of Elasticsearch to a specific physical region in the world. as a conclusion, I would like you to remember the word simplicity. It's really important for us, DevOps, to have a good communication with our dev team. As soon as they understand why to have a clean JSON is important, to have clean variable names, it will be way more easier for us to create good templates, good patterns, to have an efficient log, and it will save you time, and it will save you a lot of work. Thank you.
Sorry, what's scatting out there? I never heard of that. I can't answer any questions these seconds.
Yeah, that's really sure. Scatter is a technology on the network card which permits to, how to explain it properly, to fragment, for example, to fragment specific bits of communication, if I do remember well, but it messes with the kernel and the network card.
Cool, thank you. Okay, anybody else got a question? Taj.
How do you deal with new inputs that fail the grok parse in your log collection tools?
Well, usually we don't use grok anymore. You mean like, for example, a KV message? Or any HA proxy, for example, any Nginx. This is something that's grok and regex. It took so many time every time to check that everything was alright. We decided to write our own Golang tools just to parse everything. And with Golang, usually it's way more easier than you use grok. And after we format them and we send everything to the queues or directly into a file, and or logstash directly as well.
Cool. Anybody else got a question? Yep, come over there.
Hello. Yeah. I wanted to know if you have to manage sometimes logs with different format from maybe different application written with different language, JavaScript, Java.
Well, no, usually what we deal with is really only JSON formatted logs. It permits us to have like a unity. If all our services produce JSON formatted logs, it will permit us to have like real clarity in everything we do, and for us it will, as I said, like save us a lot of time. But no, we don't deal with all the formats. Otherwise, we transform them into JSON.
Thank you. Good question. Next, over there.
Hi. My question is about index splitting, basically. So, what's the strategy to define what goes to summary and what goes to raw? Especially if you're just using FileBit to push your log to logstash.
Well, usually what we do is we are using the queues to send the summary sometimes, and otherwise we push everything to the file, and after.
Sorry.
And after logstash, we'll check. Sorry, I'm sure. So usually what we do is we check the message type and the message type, if it's equal to summary, we will send it to summary index. And can you repeat just the end of your question? Sorry.
Yeah. So I'm wondering, on this server side, how do you define what should go to log and what should go to summary?
So actually, this is not just on. It's more on the software itself. We talk with the dev, and the dev we explain him. Okay, you have one message. It's going to be summary, and in this message, try to push everything which is important for you, which you want to see on the Kibana. Like any metrics that you care about. Like don't try to make it a cabbage as well. Like to put everything in it, but try to be like it's a proper summary for one request. So work on it and put everything you care about in it.
Cool. Raj?
Yeah. Listening to everything that I've heard so far, all of your logs seem to be predicated on everything operating normally. How do you deal with error messages and exceptions to the norm?
Yeah, so it's exactly what I was talking with the JSON parsing failure. It means that if actually it's not properly encoded in JSON, it means for us that there is an issue. For example, very simple, a Golang, a panic. It's really hard to catch, and how do you deal with it? Then it goes to the file, and the file gets will say, oh, I received a multi-line, and it's not JSON, what should I do with that? Send me an email. And in my email, I will steal that, we go to panic. So that's the way we deal with it.
Great. Any more? Over to Rory.
Actually, I was a bit more concerned about how big is your email account if you get an email for every JSON?
Well, actually, now our account is very small. So basically, I showed like an email just as an example, but you can have anything you want. It can be a Slack channel, it can be whatever you want. No, my email, no.
Okay, any more? All right, Marcus, I'll let you have the last word.
You seem to have a very good setup, and based on how many ELK setups I saw, it's usually just let's get a bigger server and just push up as much as we can. My question is, why did you even decide to tackle this problem? Because essentially there's so many SaaS products in the market, and there's Graylog and some more simple solutions. And with ELK, you need a dedicated kind of team. You need to constantly be up to date, because ELK still is releasing new features all the time, just like FileBeat, and so on. So why did you decide to go with ELK?
So ELK, I love all the products that they made. For me, it was one of the first real good products I had in my hands, so I was really attached to it. So I wanted to continue with it, but even with all the structures, I tried like Graylog, I tried some other Datadog, for example. It was really nice, but I prefer to keep it on my ELK cluster and just keep moving with it. And now it's a very autonomous system, so we only have very few bugs. And I try to optimize everything to keep on it. And now it's very autonomous, and we don't have to do any maintenance on it. It happens one every. The last bug we had was 1 week ago, and I didn't touch the cluster for 7 months. So I think the ratio between uptime and bugs is pretty small.
Marcus Maxwell demolishing people's personal projects and selling into SaaS since 2014. Vincent, thank you very much.
Thank you.